So, hello, LeetCode on a Fluke. Yeah, we're live. Yesterday, I was working on this problem, and it's called minimum path sum. And I figured out I figured out a dynamic programming solution to that. I hope I'm sharing. It shows that I'm sharing. Um, and I found a solution. There was a bug um, because I was just one of my checks. Yeah, I missed something in the check, one of the checks, but eventually it worked. Yeah, with the help of ChatGPT 04, which was, impressive in finding the bug. Really impressive, I would say. But anyway, so what I'm happy about is that my solution, the solution I figured out worked. And I had a feeling that there is probably an even more concise, more simple solution. I used like sort of um, sort of a breadth first search here, um, which was eventually just a queue of nodes, eventually just one with one loop. But there is a simple through loop solution to this one. I mean, if you go and think about it, and once I solved it, I saw a couple of examples of other solutions, and there was one that just was really simple, and I wanted to go over it today for just review it. Yeah, because my solution was based on going filling a queue of nodes in a separate dynamic programming map. I would store the solution for the sub problems, and that's kind of was my approach to using the previously solved sub problem to build to solve the next sub problem until we get to the final square, final place in the grid, to the finish. And at some point, I saw that these external rows, this outer layers, this one and that one, they have only one solution to them. It's not like you go up or left. You can only get here from the left. Okay, let me go through the problem again, just quickly to review the problem statement. So we need to find the minimum path sum from the left top position to the bottom right position. One of the paths will have, when we sum the values of the when we add the values of the squares one to another, we'll get a sum of the path, and one of them will have the minimum sum, and we need to find it. And the key thing is when the grid is 200 by 200, it's a very large number of paths, and that's why we were thinking about a dynamic programming solution, and one of them was basically it was to look at, to see if we can use the solve smaller sub-problems and use those solutions to solve the next one. And you can get from the left top to the bottom right only by going down or right. So, and that really helps to make it very easy for solving these outer layers. And we probably, can we do that also for these outer layers? Well, yeah, I mean, if we go that way, yeah, we also could do that. But I mean, if we start with the starting point and calculate the path, like the path from 1 is 1. There is not, the minimum path is 1. There is nothing else. The path from starts to 3 is 1 to 3. There is no option to get from the top. There is only 1 to 3. So we add 3 plus 1, and so on. The path to 1 from here, it will be the sum of all these, and so on. But I'm just should I go through my yesterday's solution? I mean, after I saw this very optimized solution, I liked it so much. I mean, I'm glad my solution worked, but yeah, it had a couple of things to optimize. It turned out you could use the grid as for your memory. You don't need a separate memory like this map here. And what else? And so in that solution that I figured, we had a queue. We check if there is up and if there is left, find the minimum of those, and record it in our DP. And then we queue the next ones. The next ones that actually are valid, that within the grid, and we try to avoid duplicates here. It's somewhat imperfect, but it worked for all the test cases. And at the end, we just look at this last node in our DP. Okay. But let's look at this. I mean, this logic is more generic, but for this specific case, there is even a shorter solution. And as I started saying, so if you just the outer layers are pretty simple to calculate for our DP, and we can just sum all the previous sums because there is no other option. That's the minimum path. And this inner, or this subgrid, without these outer layers, it's not all, just the left and the top layer, okay? Without them, the subgrid, then it becomes, you don't have to deal with this going out the boundaries, and you can calculate the minimum, because you'll know the minimum for the top, you know the minimum for the left, there will be in the grid already. So you just put whatever is the minimum here, and you go to the next one. This one is calculated whatever is the minimum here, and you actually don't need to go diagonal, which was the problem I was trying to solve yesterday. You can actually iterate, go over that matrix row by row, and that's it. You update the values. That's kind of the basic logic. Update the values, and you use that that same grid. So we could actually delete all that, and we're not going to need the. We're going to need that. In our DP, we'll have that. That's the last, the end row. Grid. So we'll return whatever is at the end of the grid. And so we'll use the grid to store our sub-solutions. It's pretty short, actually. It's funny how, I mean, it's freaky and it's nice and, I mean, short and sweet. I like it. So, yeah, we take care of the first row of this outer, the top row. All right, so that will be, we need to go for I is a range. Well, we can call it C, so that's a column. Okay, range calls, because that's what we have. And by the way, no, we need to start it. We need to start it from 1, because the previous one is already solved. And as long as this, should we call it column? We just call it I, right? Yeah, let's call it column. I want to be different today. Yeah. So as long as column is less than calls, and column plus, okay? So all we need to do is say that grid, and we're talking about the row 0, okay? And column C, we say that it's grid row 0. It's plus, yeah, so we add the previous value minus 1. So because it was 1, we add the previous path, minimum path, and that's it for this layer. Special case. Now this row will also need to go over the rows. Yeah, so we'll go over the row. We'll start with row 1, and that's column 0. Row 1 minus 1, column 0. Yeah. Now, yeah, we'll take care of this one. Yeah, so that will be like 3 plus 3 plus 1 will be 4. So here we'll have 4. Then 1 plus 4 will be 5. So the minimum path to get to this one is 5. Yeah, to this one from the beginning. Now, okay, so we took care of that. Now all these are updated. We need just to go over for row. Again, we need to go over the rows, but yeah, so row is less than rows. A row plus plus rows. So that gives us this row, and then that row until the end row. And we also need to go over columns, and they will also start with 1. Calls plus plus, and then we just say that the grid at this row and at this column, which will start here, is minimum of the minimum between grid the top and the left. Okay, the left and the top. Let's the value in our grid dynamic, in our sub-solution. So that will be for row. If we say let's start with left, so that will be the same row, column -1, and grid this row -1 and the same column. And that's it. Is it working? Okay, it looks like there is some kind of bug I missed. So I missed something. Okay, what did I miss? So it gives a smaller number. Are we returning? So that's row is the length, so -1 will be the last row. Columns will be the last, yes. So we need to return that. And basically, I'm just retyping. I just looked up. That's the solution, and I'm retyping that. Not retyping. I mean, I'm going over it and copying it basically. Timing, and I wanna. Okay, where is the bug here? Where is the bug? Okay, we're dealing with. So we updated this grid from 1 till the last 1 and row. So let's review these and let's just check these. So this takes care of this first row, which is row 0 on the grid. We start with column 1 until the last column. And we go one column after another. And on the grid, so we say row 0, so that first column. is now grid row 0, column -1 plus, is now incremented by the previous. So that should be right. Now the same thing for rows. The same thing we do for rows. And then we iterate over, we start with row 1. So that will be, we start with row 1 and we go over the columns of this row, starting with 1, columns less until columns less than columns plus plus. So this could be the, maybe, where did I miss it? So row and column, it's 1 1 initially. Gee, yeah, we need to add the we need to add the value of the row itself. So the minimum between those, I mean, so that's the bug. And geez, I mean, isn't that sweet? That's it's a nice and short solution for this specific problem that use every other sub problems, which is this n by n sub problems. That's, I mean, it doesn't get any better than that, I think. Maybe it does, but I can't think of it right now. We just took care of these 2 special cases, and the rest is just very straightforward. And these special cases are also straightforward. We could get rid of these, but then we'll need to use a length, like in this. It will be a lot of length. In this case, we just use columns. I mean, it's still pretty readable here. It's length. It's called code golf. I learned this idea of just making it as short as possible. Making code as short as possible. I don't know if I need to play the code golf. And by the way, I mean, if we to play a little bit of code golf, we would just do this, and that should be it. Such a short and sweet solution, which solves, I mean, this problem in linear time and fixed extra memory, because we're not using linear. It's constant memory. So nice and sweet classical problem with such a cool solution. It would be nice to learn to get one of these. I will see if we can get one of such cool solutions in our next challenges. So that's it for this one. I'll see you guys in the next video.